According to a recent survey, the overall prevalence of malaria in Tanzania is around 7%. This means for every 100 people you meet, there's likely 7 that will have malaria. There's a great chance you have either suffered from this disease or know someone who did if you live in a tropical country like Tanzania. Born and raised here in Dar es Salaam, I've also had my fair share of suffering from this disease. It did not stop there. I've gone seeing my loved ones suffering from malaria as well. I remember when I was 9 years old, seeing my mother battling through cerebral malaria. Or many years later, seeing my fiancée, now wife, being admitted for several days in the hospital with a severe case. Now, where has this disease come from? Historical evidence shows us that malaria is as old as mankind. It is a disease that has scourged us since the dawn of civilization. According to the 2020 World Malaria Report, there were around 229 million cases of malaria in 2019. Around 94% of these cases occurred in Africa. Out of these, 409 cases resulted in deaths, most of them being children under the age of 5 years. It is said every 2 minutes a child dies of malaria in Africa. But why is a disease as old as malaria still around? We know that malaria is transmitted by mosquitoes. So if you control mosquitoes, you control malaria. To date, that has been done primarily through bed nets that contain insecticides. Over the last 2 decades, bed nets have been the cornerstone of the fight against malaria. Almost 70% of malaria cases have been prevented since the year 2000 thanks to bed nets. However, recent research shows us that there is an increase in the mosquito's ability to resist the insecticide present in bed nets. Furthermore, bed nets are as old as malaria itself. There's evidence of bed nets used in Mesopotamia, ancient Rome, and ancient Egypt. A colleague of mine always says, the best tool we have against malaria is as old as malaria itself. But why have we waited for so long for such a promising tool to fight malaria? It is time for malaria researchers to start thinking outside of the box and outside of bed nets. Novel approaches are needed at this pivotal moment in our history to get rid of malaria. Imagine a world without malaria-transmitting mosquitoes, or with mosquitoes that cannot transmit malaria. This means a reduction to 0 in malaria cases and deaths. This means the nearly $3 billion in funding needed for malaria control and elimination can be channeled for other purposes. This means the nearly $12 billion that in economic loss can be averted. Ladies and gentlemen, such a world is possible with the use of genetically modified mosquitoes with gene drive, known as hybrid mosquitoes, as an additional control tool to fight malaria. Now, when I tell my family and friends that I work with genetically modified mosquitoes, they always laugh. I'm asked, how can you genetically modify such a tiny creature? It turns out that yes, you can genetically modify a mosquito such that it cannot transmit malaria. Now, if you think you're too small to make a difference, you haven't spent a night in a room with a mosquito. The genetic modification in these mosquitoes come in 2 major forms. One is a genetic modification that impairs the mosquito's ability to reproduce, and thus over time aims at eliminating the mosquito from the population. This is known as population suppression. Second is a modification that impairs the mosquito ability to transmit malaria parasites, and thus over time aims at introducing a new mosquito into the population. This is known as population replacement. Now, these modifications are passed on from parents to offspring through a super Mendelian form of inheritance known as gene drive, that ensures each offspring in each successive generation has the modification. Now, I'm sure many of you are saying, what can hybrid mosquitoes offer over current tools to control malaria? Hybrid mosquitoes are efficient, they are long-lasting, and they're easily accessible. Hybrid mosquitoes are efficient because there is near 100% guarantee that they will have the genetic modification for altering or suppressing the target population, which means they're efficient. Current tools are only effective if they come into contact with the mosquito, which is not always the case. Hybrid mosquitoes are long-lasting because the genetic modification will exist from generation to generation as long as the mosquitoes are reproducing in the target population. Current tools such as bed nets lose efficacy after some time and need to be replaced. Hybrid mosquitoes are easily accessible because they can spread from one location to another and they do not require any infrastructure to be in place. This means hybrid mosquitoes could be used to serve those areas that are limited in infrastructures. Current tools require adequate infrastructure to be in place, such as warehouses for storing bed nets, roads and vehicles for transporting control and treatment tools. Now, I'm sure many of you are thinking, yes, hybrid mosquitoes have the potential for positive impact. But what about ethics, safety, and governance concerns? Some of these concerns include, what happens to the ecosystem if malaria mosquitoes are eliminated? Can hybrid mosquitoes cross across national borders? Can hybrid mosquitoes become spreaders of other pathogens if they become unable to transmit malaria parasites? Recent reports from the WHO, African Union, and the Lancet Commission all advocate for a cautious and stepwise step in research and development in hybrid mosquitoes. There has never been a technology that is 100% free of any risks. However, if the potential benefits of that technology significantly outweighs its potential risks, then by all means it should be adopted. The world should not pass up on a chance to reduce cases and deaths in malaria, especially in children under the age of 5. Fear is often the problem and not the technology itself. Decisions on whether to proceed with this technology should be solely based on science. Only science will be able to inform us if this technology could be used in the continued fight against malaria or otherwise. Such research should be carried out in phases and be supported by clear governance mechanisms to evaluate for health, ecological, and environmental implications. In order to ensure this, certain issues must be in place prior to onset of any research. 1. Development of guidelines and frameworks for oversight at institutional, national, and global level. 2. Internationally recognized risk assessment tools and procedures should be used for biosafety evaluation. 3. Capacity building in terms of infrastructures and local skilled personnel for carrying out and handling the technology. And 4, community engagement that is locally driven. Community members must be engaged from the beginning. They must be fully aware of this technology and must be involved in the planning and implementation phases. Lastly, there are over 3,500 different species of mosquitoes. Out of these, 400 belong to the genus Anopheles. About 70 have been confirmed by research to transmit malaria globally. Out of these 70, 4, that is Anopheles gambisensis strictus, Anopheles colutzai, Anopheles arabiensis, and Anopheles funestus are the major transmitters of malaria in Africa. The hybrid mosquitoes being discussed here only target one of these 4, and that is Anopheles gambisensis strictus, which is the most efficient malaria vector globally. Hybrid mosquitoes offer a novel and uniquely transformative way of fighting against malaria. It is time to believe in our scientists, believe in their work, support them, and stop the fear-mongering. We should be the generation that ensures that no child or pregnant woman dies of malaria. We should be that generation that ensures that no 9-year-old boy has to see his mother battling through cerebral malaria. We should be that generation that ensures that no young man or woman has to see his or her fiancé battling through severe malaria. We should be that generation that rids this world of malaria. Thank you.